Hey everyone, welcome to my channel. Today we are going to build this amazing educational game which will allow kids to learn which objects are eatable and which objects are non-eatable. So here, for example, you can see that we have a chair falling, we have a laptop falling, we have some fruits, we have some vegetables. So all these different objects are falling, and what you can do is you can open your mouth and try to eat them. So right now it's on one side. Let's see. If I open my mouth and eat something which is non-eatable, it will say game over. I can press the R button and start again. There you go. I ate one apple and you can see it says here one. And then if I open again, I can keep eating the fruits and the vegetables, things that are eatable. And then if I eat something that is non-eatable, then it will be game over. So you can use this to teach kids a lot of different things, the difference between fruits and vegetables, the difference between maybe cars and buildings. You can be as imaginative as you want. And this is a very fun game. And we have written this in less than 120 lines of code. It's very simple, very easy to follow. And we will go line by line, step by step, so that everyone can follow. It is beginner friendly as well. So stay tuned and I will teach you step by step how you can create this for yourself. This video is sponsored by ClearML. Do you want to know how machine learning and computer vision are done in the industry? Well, we all love running experiments and notebooks to learn really fast. But when solving problems in the real world, things tend to get really complicated, but that just means there's more to learn. ClearML, an open source toolbox, will help you bridge the gap between learning and actually deploying your projects in a way that's scalable to thousands of users. If you love machine learning and are looking to make real impact with your skills, you can get started for free in 10 minutes. Check out ClearML and let them help you take your projects to the next level. If you would like to level up your computer vision skills, do check out our premium courses that are available on our CV Zone platform. Links are in the description. So without further ado, let's get started. So here we are in our PyCharm project, and the first thing we will do is, as usual, we'll go to File, we'll go to Settings, and we will go to the Interpreter, and we are going to install the packages that we require. So the packages that we want are OpenCV, CV Zone, and we also need Media Pipe. So we are going to install all of these. We will install CV Zone. That will automatically install OpenCV and NumPy, so we don't have to reinstall those. Then we will go to Media Pipe and we are going to install that. So let's go ahead and do that. Media Pipe. Now there's an issue with the newer version of OpenCV that it might not show you the suggestions. So if that happens, you can revert back to the previous version. So we are going to try it. If it doesn't work, we'll go back to the previous version. So it is installing Media Pipe at this point. So, and it is already installed. So we will start by importing our packages. So the first thing we need is a webcam. So we are going to install the webcam. So let's write here import CV2. And then we also need imports, or let's not do that now. Let's just start with the webcam and then we'll move on. So for the webcam, we simply need cv2 dot video capture. So as you can see, it's not showing the suggestion. So we'll go to File, we'll go to Settings, and we will go to OpenCV Python. We'll double click it. We will specify the version. We'll go back a few iterations, let's say 0.60, and then we will install again. So hopefully this will solve that problem. So we will give it a minute to resolve, and it has been resolved. So let's try it again, cv2 dot video capture. So now you can see it is actually giving us the suggestions, so it will be much easier for us to work with. So cv2 dot video capture, and we will capture ID number 0, and we will store it in a variable called cap. So then we are going to write here while and true. Then we are going to write that the success, this is a boolean, and then the image equals cv2 dot cap dot read, and we are simply going to read the image. It will store it in the variable image, and then we have to display it. So we write IAMShow. We want to display the image, but we want to give it a name. So let's give it a name of image. And then we are going to write cv2 dot wait key because we want to add a delay. So that delay will be 1 millisecond for now. So that should be pretty much it. So let's go ahead and run this and see if our webcam is working. But before we test, I have to change this to number 3 because I have multiple cameras installed. So this is the one that we are going to use for our game today. So let's run this and see if it works. It's taking a while. And there you go. So now you can see me. But here I can see an issue. There's a little bit of delay because I'm using a lot of things and I'm recording on a laptop. So that's why it's a little bit laggy, but hopefully that will not be your case. So here, one thing we have to do is we have to set the size of the image because we are going to use again and again, we are going to use some hard code values, some very specific values. So we need to make sure that we are using the correct numbers. You could make them variables. You could actually make it dynamic and change them. But for now, to keep it simple, we are going to hard code it. So here we are going to write cap.set. We are going to set number 3, which is the width. And we are going to set it to 1280. 1280. And then cap.set, we are going to write number 4, which is the height. We are going to set it as 720. So this will be our standard size that we will be using throughout our game. So let's see how that looks like. There you go. Now you can see me. Let me move it a little bit. There you go. So now you can see me. It's working. But as you can see, it's lagging a little bit because I'm recording, I'm trying to access other cameras, and then a few of the softwares are open. So there's a lot going on. Anyways, so let's move ahead. And the first thing we have to do is we have to detect the face mesh. So we need to find the face, and within that face, we need to find the lips. So the idea is that if we open the mouth, then only we should be able to eat. And then we will look at the falling objects. So you can start with the falling objects as well, but we are going to start with the face mesh. So here we are going to write from cvzone dot face mesh module import face mesh detector. And if we click on control, if we press the control button and we click, then it will take us to the class and it will define what it does, how it works. And then at the end, in the main, it will show us an example code. So here you can see it shows that you have to write the detector. So let's just copy that. So here we will write detector equals face mesh detector. And the number of faces we are going to detect are 1. So we should not exceed more than 1. Only one player is going to play the game at one given time. So then we are going to look at how exactly can we detect. So here you have to write detector dot find face mesh, and you have to give in the image as the parameter. So we will copy that, and it will return you 2 things. It will return you the image, and it will also return you the faces. So all the information will be within the faces. And then if the faces are present, then we can get one of the faces and do something with it. So let's just put that here for now and let's try it out. So by default, it is going to draw, so we can see if it's drawing properly or not, if it's detecting properly. And then based on that, we can find the points. So here we can see this is the output of the faces. So this is one of the face that will have around 400 parameters, each of these points. So let's go ahead and test them out. So there you go. This is the face mesh. We can see it's moving around. It's all good. And this is the point here. You can see on my lips, these are the points that we need to find. So we don't need a lot of points. All we need are 4 points for the top and the bottom and the left and the right. So these are the 4 points that we need to check if the mouth is open or not. Now you could use only two, up and down. You can use only two of those, but then if you move back, the distance will change. Basically, we are trying to find the distance between these 2 points. So if I'm close, the distance will be higher, it will be more. If I'm backwards, the distance will be lower. So we need to avoid this. That's why we will take a ratio. Instead, we will take a ratio of the upper and lower versus the left and right. So the distance between these two. So we will take the ratio of that, and that will remove that part where you go back and it changes the value. So the ratio should stay the same, because if you go back, the distance of the upper and the distance of the side will change proportionally. So that should give us some good values. So let's stop this. And here what we are going to do is we are going to find those points. But how exactly can we do that? First of all, in faces, we are getting multiple faces. It's not just one face. So we need to find that one face first. So that one face, we can call it face equals faces at 0. So faces at 0 will give us the first face that it detects. And because we can only have one face, it will always be the 0 value. So that's why we are confident and we are writing it directly. So face equals faces at 0. Now, what we can do is we can draw the points and we can see their numbers. So how can we do that? Something is wrong here. Let's go back. It's probably the indentation. There you go. Face equals faces at 0. So that's the idea. And then what we will do is we are going to draw it. So we want to draw it, we want to put the text of that number. So for example, what does this value correspond to which ID? Which value corresponds to this ID? So we need to know the lip, and we need to know the upper lip, the lower lip, the left and right. So we need to see these points. So this can be a little bit difficult. So what we can do is we can write here cv2 dot put text, and here we are going to put it on our image. Let's say we will put ID number. So we will write here ID number. Right now ID number is not defined, but when we start the loop, we are going to add the ID number. Then the origin should be the face at that ID, right? So here we are going to write, let's say ID, and then we are going to write the font cv2 dot font. You can write any font, and then you can write a scale. Let's say 1. 1 will be big, so let's write 1.0. Let's say 7. Then color, let's say 255, 0 and 255, and the thickness, let's put it as 1. So now we need to put it in a for loop, because we need to go through all the 400 values. So we need to write for all of them, we need to do this. So we are going to write here for ID in face. We are going to loop all of those, but we also need the count number. So which number iteration are you at? So to do that, you can simply write enumerate, and you can write here ID number. There you go. So now it will give you the ID number, and it will also give you the ID. Or instead of ID, let's write it points, or let's write it points. So that is 1 point that we are getting from the face. So here, instead of ID, we are going to write points. So that's the idea. And then we have to change this ID number to a string, because we are putting a text, and the text cannot be an integer. So we are going to write here string, and then we will write ID number. There you go. So let's run that and see if we get any good results. So that will give you an idea of where each of these points are. So sometimes the maker of the library will also tell you where each of these points are. But if they don't tell you, this is the way how you can find it. And that's how we will find it as well. So there you go. Now you can see all the points have been written down. So if I come close, you can see the topmost is 10, 338, 297, and so on. So these are the points. Now what I did was I played around with these values. I made the text smaller and I tried to figure out the closest point to the lips. So I have tested them out, and I will keep this here in case if you want to do it yourself. But here are the IDs of the points. So we will write them as IDs. So let me see what were the values. So let's call it ID list equals, it was 0 and 17. This is the lower and upper. And then it was 78 and 292. This was the left and right. So to make sure we have the correct points, we can loop through these points and again we can plot them. So here we can write for ID in ID list, we are going to write cv2.circle and we will put it on our image, and the center will be the ID, and the radius, let's say 5, the color, let's say 255, 0 and 255, and the thickness, let's say, is 5 as well. So let's try that out and see if it gives us the correct points or not. So there is an error. Let's try to see what the error is. Error, bad argument in circle. So cv2.circle image ID. Oh, we cannot just put ID. It's the ID number, and we need to put the actual point. So it will be face at ID. So we need to get that point. My bad. So let's run that and see if it works. So there you go. Now you can see the points on the lips. And if I open my mouth, you can see the points are correct. So the left and right, the up and down seems fine. So we can go ahead and try that out. So now let's do one thing. We'll create a line as well. So from the top and bottom and left and right, just to make sure that we are headed in the right direction and looks a little bit better as well. And we will also remove the drawing. So we will write draw equals false. So we don't want to draw all the 400 points. We just want to draw the points on the lips, and that's it. So here we have that circle, and then we are going to draw two lines, cv2 dot line, and we have to give in our image. We have to give in point number 1. Point number 1 will be face, and from that face we need the ID. So the ID will be within the ID list at point 0. This is our first point, and then the second point will be at number 1. Then we will give in the color. So the color, let's put it as green. So BGR 0, 255 and 0. And then the thickness, let's give it as 3. So the same thing we will do with the other line, and instead of 0 we'll put 2 and 3. So that's the idea. Let's see if it works out. There you go. Now you can see on my lips, you can see that it is showing the lines as well. So if I open my mouth, if I stretch, you can see it's working fine. There you go. So we are headed in the right direction. It's all going good. Now what we need to do is we need to find the distance of these lines, and we need to take the ratio for them. So we need to find the distance of up and down, and then we need to find the distance of left and right, and then we need to divide them to find the ratio. And that ratio will tell us if the mouth is open or not. So let's go ahead and do that. So here, to find the distance, we already have a function in CV zone. So what we can do is we can write CV zone dot, we didn't import CV zone, so we'll write here import CV zone, and we will go down and we will write CV zone dot find, or is it in CV zone, or it's in the detector as well. So we can write here detector dot find distance, and we will give in the 2 points that we need to find the distance between. So the first point again will be ID list 0, and the second point will be ID list 1. And the same thing we will do here again for number 2 and number 3. So we will call this up down, and we will call this left right. So these are the two that we are going to use, and then using that we can find the ratio. So how can we find the ratio? We will simply write ratio equals up down divided by left right. Or should we do the, you can also write vertical and horizontal, it's up to you. So up down will be yeah, okay, let's try this and we'll see. Print ratio, and then we will keep the mouth closed and see what the values are. Then we will open the mouth and see what the values are. So hopefully it will give us different values, and that will allow us to differentiate if the mouth is open or closed. Oh, there's an error again. I made the same mistake. I forgot to write the face. Come on. It's the second time I'm doing the same mistake. Okay, so we need to use the face. There you go. And let's run that again and see if it works. Okay, we are getting another error, and this is because the find distance returns two things. So the second one we are going to ignore. We can also multiply this by 100, because most probably they will be very small values, so it's decimal places. And we can also convert it into an integer just to make it a whole number, which will look nicer. So let's try that out, and hopefully this time it will work out. So now you can see that we are getting some values. So if I open the mouth, you can see the value goes higher. If I close, the value goes lower. So now we have a clear indication of when the mouth is open and when it's closed. So we can find a threshold. So somewhere in the middle, yeah, so around 60 plus, we can say the mouth is open, and below that, the mouth is closed. So we can directly indicate that by writing here some text. So we can copy this text part because we are extremely lazy, and we can remove that. And here we can write that if the, oh, I'm writing English. So if the ratio, let's say, is greater than 60, then we are going to write that, or let's put it as a variable. So we will write that. So here we can write mouth, let's say status equals open, and else we can write mouth status equals closed. So, and then we can use the mouth status to actually, what is happening? So we can use mouth status to actually draw on the image. And here we will write mouth status point. You can give any point, let's say 50, 50. Let's make this bigger. Let's say 5 and 5. Let's see how that works out. So let's check that. Oh, it's too big. So let's make it a little bit smaller. 2.5 and 2.5. Actually, let's make that 2. And let's make this 2 as well. So there you go. Now it says closed. And if I open the mouth, it says open. Works well. So that's the main idea. So here, even if I'm talking, it's not saying open because we have set a good threshold. If you want to make it a little more harder, you can increase the threshold as well. So that's the main idea. And if you want to make it a little bit easier, you can reduce the threshold. Okay, so what happened? I accidentally pressed a button. That's what happened. Okay, so the next thing we have to do is we have to start bringing in the objects. So which objects are eatable and which objects are not eatable. So whatever they are, we need to import those images and we need to drop them one by one so that we can play the actual game. So where are these objects? Let's bring in the folder. So I will just drag this folder in and we will refactor it here. Now, these objects will be available for download on our website for free. All you have to do is you have to sign in. If you haven't done that already, just sign up on our website. It's free, and then you can download these resources. And the code will also be available on our website. So if you double click on objects, you have eatable objects and you have non-eatable objects. So both of them are 4 objects. So here we have an apple, a mango, and then a pineapple, and then a carrot. So these are the 4 things that are eatable. And then for non-eatable, you have a bomb, you have a laptop, you have a mouse, and you have a chair. So these are the 8 items that we are going to use today. So what we need to do is we need to import them one by one, and we need to put them in a list. So there will be an eatable list and there will be a non-eatable list. And based on that, we are going to grab one by one of these objects and we are going to drop it on within our game. So here we are going to write import images. So what we need to do is we need to find a dynamic way to actually import all the images that are present. So we cannot just hard code to import 4 images. So we need to check the folder, how many images are there, and based on that, we will import all of these images. So first of all, we need to know where the folder is. So we are going to write here folder eatable equals, and then we are going to give in the location of that folder. So it's in objects/eatable, and then we are going to find the names of all the folders or images that we have. Actually, let's just comment all of this out just for now. You can press Control and backslash to comment everything, and here we are going to write list eatable equals os dot list directory, and we want to list the directory of our folder eatable. So let's print that out and see what we get. So let's run that, and there you go. We have 1.png, 2.png, 3.png, and 4.png. So these are the name of the images that we have, and based on that we can import them. So we can simply write here for let's say objects in list eatable. We are going to import all of them. Then we need to save them in a list of the actual images. So we will import the image and we will put it in a list. So that list, we can call it eatables. Eatables equals empty. So we will say that eatables dot append. Then what we need to append, we need to append the image that we import. So we will write cv2.imread, and what is the file name? We need to give that. So we'll put an f string, and within that f string we are going to write first of all the folder eatable, and after that we will have the name of the object. So object, again we'll put that, like this. And we, at the end, we don't need to do anything else, do we? And then what we need to do, because we are importing PNG images and we want to use the alpha channel, which means we want to remove the transparency at the background, we need to write here cv2 dot imread unchanged. So do not change the image when you import it. That's what it means. So based on that, if you don't do this, it will not work. So we are going to use a function later to draw the PNG image with the transparency on our main image. If you don't do this now, it will not work there. So that's very important that you do this. So that's done. And what we can do is we can draw one of these images on our main image to see if it's working fine. So we can uncomment all of that. Again, press Control and backslash, it will uncomment. So here, right at the end, what we can do is we can write here CV zone dot overlay PNG. We will give in the background image, which will be image, and then we will give in the front image, which will be eatables at 0, let's say the first image that will be of an apple. And then we will give in the location. So let's say 300 and 300. So random. Later on, we are going to keep changing that so that it drops. So let's run that and see if it works. Okay, so the image is not displaying. Why is that? Ooh. Oh yeah, we need to put it back in an image. That's it. So that should work fine. Let's run it again and see if it works. So there you go. Now we can see the apple. Now the next step would be to drop this apple so that it looks like it's moving and it's dropping down till the end. And when it reaches the end, we need to reset it back to start from the top. So we will create a new function for that to reset, because there will be multiple occasions where we want to reset. But for now, let's just change the position of it. So let's bring this part right at the top. So, or should we put it in the face, or I think it can be without the face as well. So let's put it here, and we need to change the position of it again and again. Actually, before we do that, let's import the non-eatables as well. So let's just copy all of that, and let's just paste it here. And we will, for each one of these, we'll just write non. Folder non-eatable. This one was eatable, so we will write here non-eatable. Folder non-eatable. List non-eatable. Here we will also write non, and we will put the capital E because we are using camel casing. That's why. Object list eatable, we will write here non-eatable, non-eatables. Then folder non-eatable, and that's pretty much it. So now we can check the non-eatables as well. Let's just write here non-eatables, and let's import that image as well, just to test out if everything is working fine. So there you go. You can see the image as well. Non-eatables have been imported as well. So that's good to go. So now the next step would be, what we were about to do is to drop the object. So let's keep this. We will call one of them as the current object. Current object equals, let's say, eatables at 0. So this will be the first object that will drop, and then later on, whenever it resets, it will bring up a new object. So here we will write current object. There you go. So now we have this, and we need to make this dynamic. So we need to move it. So this will change, and this will change as well. So here we will write position equals we will give in two parameters. The first one will be the x and the second one will be y. So for the starting one, we will give in the x, let's say at 300, and the y, we will give it at 0. So it starts at the very top and then it drops down. So here we will give in position. Instead of writing this, we will write position. There you go. And then what we need to do is we need to change the position each iteration. So we will write position at 0, not at 0, at 1 plus equals the speed. So we can set the speed. If we want to go faster, we can set the speed faster. So here we will write speed equals, let's say 5. So it will move 5 pixels each iteration. If you make it 50, it will go really fast. So it will be very difficult. If you make it 1, it will be very slow. So again, it's up to you. You can play around with these values and see how that works. So let's run this. Now, hopefully it will drop down. And at the end, when it drops and it has no more place to go, it will give you an error. Because when the endpoint has reached and there's no more space to go, it won't be able to find. It will say index out of range. So let's see if that works. There you go. Now the apple is dropping and there you go. There's an error. And now it will not be able to go any further. So what we need to do is, before it reaches the end, we need to tell it that reset and start again with a new object. So we will write here a function and we will call it reset object. And for now, we are just going to write here pass. We will add some other parameters later on. And then what we are going to do now is we are going to check if it has reached the end. So we will say that if the position at 1 is less than the total height is 720 minus the height of the image, which is 100 in our case, minus 50. So we are adding a little bit of a play. We don't want to go right at the bottom. So that's why we are writing this. So all of this you can do manually as well, and you can give in a fixed value. It's up to you. But for now, we are just writing it like this, or you can write here, a fixed value. For example, let's say 520. So after 520, you need to reset the position. So here, if that is the case, sorry, not less than, if it's greater than 520, then reset object. There you go. That is the main idea. And the reset object should give you a return of the current object. So here it will choose a new object and it will return you that, okay, this is the new object that you need to try out. So here it will be current object equals whatever it gives us back. And here we are going to write current object equals, we are going to pick a random object from eatable or non-eatable. So let's say from eatables, we pick up, let's say, number 2. Okay, so and then we will return current object. So again, this is hard coded, but after we see that it's working, we will make it random so that it can pick any of those objects. So here you can see the apple is dropping, and then, oh, it changed first, and then it still went down, and then it gave an error. So it means it's working, but we need to reset the position. So for the position, we are going to write, whenever you want to reset, that our position equals, again, we have to give in random values. So let's write here random dot rand integer, and then the first one, we are going to give from 0 to 1280 minus, let's say, 100. And over here as well, we will start from 100. So we don't want to go till the edge. We want to stay a little bit further. So here we can write 1180. I'm writing it like this so you understand why we are subtracting and all that. Like if I just write 1180, you will be like, why did you choose this value? So that's why we are writing it like this. And then the y will be 0. So this will be our new position. So there you go. This will happen in the reset. So let's just write it like this: position at 0, and then position at 0, and then position at 1 equals 0. So this way it will change that globally here. So then what we will do, I think this should work now, back and forth. And for the random, we can also add the random value for the eatable. So, or should we do it now? Let's do it after we see everything is working. Then we will add some randomization. So there you go. Now it's going down, and again it's going down again. It resets, comes back to a new position for the x, and then y again it will start from 0. So it is working fine. Now we need to randomize the object that it selects. So we have two options. One of them is eatable, the other one is non-eatable. So first of all, we need to select whether we are getting from eatable or we are getting from non-eatable. So we are going to get a random number, and we will write here random.randint, and this number can be from 0 to 1. It can be 0 or 1. Now this will give a chance of 50% eatable and 50% non-eatable. If you want to increase the eatables, because non-eatables should be less, then you can go from 0 to, let's say, 2. So then 2 times it will be eatables and 1 time it will be non-eatable. If you want to increase it further, it's a ratio. So now if you put 3 times it will be eatable, 1 time it will be non-eatable. So that's the idea. So let's put it 2 for now. And then we will write here, if rand number equals 0, then we are going to select only non-eatable. So we will write current object equals non-eatables at a random value. So that random value, rand.randint, should be from 0 to 3. Otherwise, else, if any of the other cases, then you are going to pick from the eatables and you are going to again use from 0 to 3. So that's the basic idea. And let's see if that works. There you go. Now it's an apple. Now it's a laptop. And then again, it's a laptop. It's a pineapple. So that's all good. So it's working and it is getting all the different fruits and eatables, non-eatables, whatever they are. Again, these are random values, randomly generated. So everything is dynamic. So again, if you want to change the ratio, you can increase here. Change the ratio of eatables versus non-eatables. So the higher the value, the more eatables you will get, the less non-eatables you will get. So now that we have the objects falling and we know if the mouth is open or not, what we need to do is we need to check whether the mouth is close to the object or not. So it should only be eaten when the lips are close to the object. So if they are far away, you should not detect it as eatable or eaten, even if the mouth is open. So if the mouth is open and the object is close, then only we will consider it as eaten. Otherwise, we will say, no, it's not. So we need to find the distance between the object and the lips. So how can we do that? It's very simple. We already have the position of our object, and we already have the position of our lips. But within that, we have a line, so we need a point. So it's better to find from the center of the lip rather than from the side. So here the points that we have are on the sides. So it's left and right and up and down. So what we will do is we will use the up and down and we will divide it by 2 to get the middle point. So we will take the x of both points up and down and we'll divide it by 2. We will take the y of both points and we will divide it by 2. So here we will write that our cx and cy, these are the center values. This will be basically the face ID list at 0. This is the point, the upper point. Actually, it will be difficult to do it like this. So let's call it up. Let's call it up equals this. ID list at 0. Can we do that? Yes, we can. So up is this. And then right here, let's write here down. So down is number 1. So we can replace this with up and down. Up and up. You can do this with the left and right as well over here. But for now, we'll just skip that. So here it's up. So up at 0 plus down at 0 divided by 2. So that will be your x. And then the same thing we will do. Let's just copy this. And at 1 and at 1. So this will give us the center point of our lip. And from this center point, we are going to find the distance of this to the object. So actually we can draw a line to make it easier for you to understand. So if, or just to check whether we are heading in the right direction or not. So here we can put it as cx and cy, cx and cy, and then the second one will be the position. That's it. So position of the object. So if our theory is correct, it should give us a line from our lip to that object. So if that's the case, let's see if it works. So let's try that out. There you go. So we are getting the fruit. Okay, we are not getting it from the center of the fruit. We are getting it from the edge, but the lip is correct. We are getting it from the correct position. So the position, should we change it or not? I think it should be fine. Or if you want to, you can write position at 0 plus 50, position at 1 plus 50. 50 because the height of the image and the width of the image are 100. So divided by 2 and you get 50. So that's why then it will be right in the center. Okay, let's try that now. And there you go. Now it's in the center. So the line and the lip, you can see the object and the lip. So what we need to do now is we need to find the distance of this line. If that distance is small and the mouth is open, then only we are going to detect it as eatable. Otherwise, we will not detect it as eaten. So let's stop that and we will write here distance of mouth and object equals detector dot find distance. It's the same process as we did here. We need to give in the 2 points. These are the 2 points that we want to find the distance between, and that's it. So this will give us the distance mouth object, and let's just print that. Print, and we will remove the ratio because we don't want to see that. What is happening? I can't spell prints. Okay. So there you go. Now we are getting a value. So why are we getting so many values? Distance mouth. Oh, I forgot again. We have to ignore the second value. So just look at the first value that we are getting here, which is 500 something. and ignore the others. So here now it should be eaten. So here you can see when it's below, let's say, what is that, 7, 8, 900. Okay, let's say when it's below 100, it's eaten, and then after that it goes back to big values. You can see that. Let's try it again. So here we are getting 900 something, 800 something. So it's not eaten. Here it's coming close. And at this point, yeah, I think maybe 60, 70, or just to be on the safe side, let's keep it at 100. So if the distance is less than 100, it means that we are close to the lip. And then if the mouth is open, then it should be eatable. Then it should be eaten. So here we have found distance of the object, and here we have found lip opened or closed. So now we need to put them together and get the result. So here we are going to write, if the distance mouth object is greater than, not greater, less than 100, and the ratio is greater than 60, both the conditions are met, then we are going to reset like this. Reset the object. It means it's eaten, so reset it right away. So we'll write here reset. So let's see if that works. So now you can see if we go close and open, it resets. There you go. I look crazy when I do that. Okay. There you go. So it is resetting. Now I will keep the mouth closed and I will go close. So it should not reset. Let's try that. That's too far. Let's just wait for the other one. See, I moved my mouth. The lip was not open. That's why it did not accept it. It did not reset. Now, if I open, it will reset right away. There you go. So it is resetting and it's working properly. So now we are coming to the end of the game. All we need to do is we need to add a counter, and we need to add when the game will be over. When you eat something which is non-eatable, it should be game over. So to find that, how we can do that. So here we can simply write count plus equals 1, and for the count we can go back after the speed. We can write count equals 0, and then we can simply display the count as a text. So we will copy that, we'll paste it, and we will write here count, but we need to convert it into string, and we will write here count, and this one we will push it on the other side. So let's say it is 1100, and yeah, that's pretty much it. So let's see if it gives us the count, and every time we eat something, it should add. Right now it will add for both of them, eatable and non-eatable, but afterwards we are going to change that. So let's test this first if it works. There you go. It says 1, 2, that one is gone, 3, nothing. So as you can see, the counter is working fine on the right hand side. It's good. Maybe we can make it a little bit bigger or thicker, maybe 5, so it's a little more visible. But anyways, the concept is working. But now we need to make sure that we only increase when it's eatable. So we are going to introduce a new variable, and this time we will make it global. It's not the best way to do this, but it is a way to do it. So global, we are going to write is eatable, and then we are going to write is eatable equals true. because the first one is eatable. We are getting the first one is always eatable. Then we will start with the non ones. Then here we are going to write that is eatable equals false, and here we will write is eatable equals true, and we need to define that again here, that we are using the global is eatable. So here is eatable false, is eatable true, and then before we add to the counter we need to check whether it's eatable or not, and we will not reset it. Actually we will reset, or we will end the game, but for now we will write here if is eatable, then do this, else game over equals true. Now we will create a boolean and we will use that as a flag for game over. So we will write here game over equals false, and we will run the complete game if the game is not over. So here whatever we are doing, apart from the image, we will write if game over is false, then do all of this, else, which means when the game is over, then we are going to put the text game over. So here we will simply write game over, and let's put it at, let me check the values, 300 and 400. Let's make this 7 and let's make this 10. So if the game becomes over, then it will show this, and then we can reset it. We will add a button to reset it as well, but for now let's just test it if it works, and if it does then we can move on. There you go. So let's not eat that. Okay, that's far away. I don't want to eat that. Again, it's far away. Let's just wait. There you go. 1, 2. Now we will eat something that we should not eat. There you go. It's a, oh, that's too big. Game over. That's fine, but it's really big. Let's put here plain, and now it should be fine. So there you go, and there you go. It says game over, and now it looks really good. So what we can do now is that we can add a button to reset, and we can write here key equals this, and then we can write if key equals ORD, and we will write the key number is, let's say R is for reset, so we are going to write that, and then we will write here reset object. We need to also reset the game over equals false, and we can also reset the count, so the count should be 0. That's the main idea. So let's click on play and let's see if that works out. So let's try. Okay, that's a little bit far. I'm not gonna jump. Okay, let's eat the chair. Game over, and we press the R button and it resets. That's good. Okay, I think there was an error here because is eatable was false. So what we can do is we can again start with is eatable true, and we will also start with the current object again. So just to make sure if it's fine. So this and is eatable is true. There you go. So that's the idea, and this time around it should not be an issue, because when we ate the chair, it accepted that as eatable. So that was not good. You can also put a random value here so that it selects an eatable, but every time it selects a different eatable. It's not an apple every time. So you can do that too. So let's try that out. There you go. Game over. Let's press R, and it starts with an apple, and there you go. Now it's fine. There you go. Game over. So this was the project for today. I hope you have learned something new. I'm pretty sure it's quite simple to understand, and we have done all of this in less than 125 lines of code. So it should be fairly simple to replicate and try out. And as I mentioned earlier, you can make it for other games, like teaching kids the difference between fruits and vegetables, animals, and living things and non-living things. And you can pretty much come up with anything that you wish, and you can add this as a game. Instead of teaching it directly, you can make it a game and let the kids enjoy as well. So this is it for today. I hope you have learned something new, and I will see you in the next one.